Alright guys, just quickly I had a few questions about question 10, varying questions, so I'm just going to run through my solution and explain a few things along the way, and hopefully that'll help some of you. Hopefully with question A, not too much difficulty, we just got to expand that out. So expanding it out, we get x squared, and then we get x times 1 on x, or x times 1 on x, that's just going to give us 1. So we get plus 1, 1 on x times x, it's going to give us 1 again, and then finally we're going to end up with plus 1 on x squared, and that simplifies to x squared plus 2 plus 1 on x squared. Moving along, question B, part I. So question B started off with, it says, if x equals root 7 plus 6. Part I said, show that x plus 1 on x equals 2 root 7. So the first thing I'm going to do here is I'm going to get what they told me x to be, and I'm going to sub it into this left-hand side over here. So my left-hand side, once I've subbed it in, becomes root 7 plus root 6 plus 1 on root 7 plus root 6. All right, and now I'm looking at that, and the first thing I'm going to do here is I'm going to rationalize the denominator on the right hand side. So I'm going to multiply top and bottom by root 7 minus root 6. And the reason I've done that, because I can see here quickly that, remember how when we rationalize it becomes the difference of two squares. Well, 7, that's going to become 7 minus 6 in the denominator, and it's going to give me a denominator of 1. So running through that, we're left with root 7 plus root 6 plus root 7 minus root 6 all over 7 minus 6. The reason that, even though I said I know this just becomes 1 because I can see it, our question's a show question, and with show questions you treat the person marking it as if they've got no idea about anything that's going on, but they can read mathematical text and notation. So you've got to spell out for them every single little small step, which equals root 7 plus root 6 plus root 7 minus root 6. That, when we collect our like surds, just becomes 2 root 7, which equals the right hand side as required. Here you can see that now I've achieved that right hand side as I was asked to do. Moving on to part 2, and I think part 2 is the part that probably caused the most issues for people. And part 2, it says use the result in part A to find the value of x squared plus 1 over x squared. So just over on the right here, I've got our result from part A there for us. And you can see I've kind of rearranged part A so that I've put that 2 at the end there. Now, hopefully we can see that this section here, and this section here are identical to each other. The only difference between these is that this bottom one here is missing a 2. So it's like we've got taken away 2. That's important. The other thing that I want to put out here is it's how the question's structured. Of course, it's a part 2 usually, and when I say usually, 9 times out of 10 in an exam situation, the HSC, when you get a part 1 or part 2 is some way related to part 1. So that tells me this 2 root 7, or x plus 1 on x, it's going to come in handy somewhere for me. Now, having that thinking where, because they're linked questions, using this idea of x plus 1 on x I might need to use it. Back in our result from part A, I also have an x and a 1 on x. So what we can think about here is that x squared plus 1 on x squared, that is just like expanding x plus 1 on x all squared and then taking 2 away from the result. By taking away that 2, we get our x squared plus 1 on x squared by removing that 2. By recognizing it was a part 2 and that this would come in handy, I can see that that's there. Now all of a sudden I've got some things that are helpful to me. So I'm going to sub x plus 1 on x equals 2 root 7. I can make that substitution. I know the value of that. I found it in the previous question. So what we end up with is 2 root 7 all squared minus 2, or 2 root 7 all squared becomes 4 times 7 minus 2, and 4 sevens are 28. 28, take away 2, 26 there. So hopefully that helped you recognize what was going on. And I think the trick to this question is, it said use part A, recognizing that x squared plus 1 on x squared is the same as what we got in part A, just minus the 2, and that the part 1 and part 2, we can recognize I've got an x plus 1 on x, so I combine those ideas to get a result of 26. That was probably more interpreting the question and how that question flows, rather than rationalizing denominators or simplifying surds where we need to. Just for fun, what I've got down here is an alternative method, another way of solving question B part 1. And it runs along the same lines. I'm not going to write it out, I'm just going to talk you through it. So what you can see, it's very much that same setup. Show that x plus 1 on x equals 2 root 7, substitute root 7 plus root 6 into the left-hand side. But instead of rationalizing the denominator straight away, what I did was I went to add fractions, and remembering to add fractions together, they need to have a common denominator. So my root 7, it needs to be multiplied top and bottom by root 7 plus 6. And same with root 6. Once I've expanded them out, root 7 times root 7 is 7, root 7 times root 6 is root 42, and so on and so forth, I get this big fraction. And then I can tidy up that numerator. We can tidy up that numerator to 14 plus 2 root 42. And then I can still see, well, I've got that irrational denominator. I know that where I'm asked to go is 2 root 7, so I don't have a denominator. So rationalizing my denominator using the conjugate. And I just want to point out that it's at this point here when I'm constructing this solution, I'm starting to notice something. I already noticed that 42, I got that from multiplying 7 and 6. And I've got to multiply 42 by 7 and by a 6 again. So as you can see, as I've done that expansion, down here I've left them as 42 times 7 and 42 times 6. The reason being, you can see in that next line, there's a mistake in my working, that should have been 6. In this next line of working out, you can see that 42 is just 6 times 7, and there is my squared numbers. There's 49, and there's 36. So simplifying these two surds, we get left with 14 root 6 and negative 12 root 7. And you can start to see that 14 root 6, those two terms will negate each other. And then 14 take away 12, so 14 take away 12, that leaves us with our 2 root 7, which gets us to that right hand side as required.